Section 5.1 Fundamental Identities. Reciprocal identities. We know that cotangent theta equal to 1 over tangent theta. And secant theta will be equal to 1 over cosine theta. Cosecant will be equal to 1 over sine theta. Okay, we learned this from the chapter 4 already. And then we call quotient identities. So tangent theta equal to sine theta over cosine theta. Okay, how about cotangent theta? Cotangent will be 1 over tangent. So you could think about it, you could flip this guy, that would be equal to cotangent. Okay, cotangent theta equal to cosine over sine. Pythagorean identities. Remember this sine squared theta plus cosine squared theta equal to 1. We cover it in the session 3.3. Okay, remember the unit circle? The unit circle equation is x squared plus y squared equal to 1. And then we say x equal to cosine s, y equal to sine x. So when you plug it into the formula, you're going to find this identity, cosine squared x plus sine squared x equal to 1. Okay, you could review the session 3.3 to figure out this identity. Since we have a sine squared theta plus cosine squared theta equal to 1, we could revise it. We're going to get 2 more identities. Let me show you guys how to get these 2. So first, we do have a sine squared theta plus cosine squared theta equal to 1. Okay, so what we're going to do, we're going to divide it by cosine squared theta for each of the terms here. Okay, sine over cosine, that will become tangent. So tangent squared theta plus cancel out equal to 1. 1 over cosine, that will be the secant squared theta. Okay, so this is how we get the second one. Okay, how about the third equations? One more time, we know sine squared theta plus cosine squared theta, that will be equal to 1. And this time, we're going to divide it by sine squared theta for each of the term. Okay, so this one cancel out, you're left with the 1. Cosine over sine, that will become cotangent. And then 1 over sine square, that's a cosecant square. Okay, so that's why we do have a free Pythagorean identity. Okay, and also the first one here. I need you guys to memorize it. And then even and odd identities, we do have a sine negative theta equal to negative sine theta. Okay, I show you guys how we get this one also. Okay, remember we do have a quotient 1, 2, 3, and 4. Right? And then that's a CAST. Right? Remember that this is talking about the cosine is a positive here. All of the trigonometric function are positive in the quotient 1. And this is going to be the sine here and the tangent here. Okay, so when we have sine negative theta, remember negative theta means you're going to be going clockwise, going from here. So let's say this is going to be my negative theta. And then think about it, sine on quadrant 4, that's going to be negative. So we do have a negative sine theta. Okay, and then tangent, same thing, tangent negative theta. So going clockwise, so it's still on the quadrant 4, and tangent in this quadrant is also negative. So we do have a negative tangent theta. Okay, how about cosine? Cosine negative theta. So negative theta is talking about in the quadrant 4. And cosine in this quadrant is going to be positive. So that will be cosine theta. Okay, you could see only like cosine is going to be positive. And then cosecant, that would be the reciprocal of the sine. When sine is a negative, cosecant is also negative. Cotangent is a reciprocal of tangent. So when tangent is negative, cotangent is also negative. Last one, secant will be the reciprocal of cosine. When cosines are positive, secant is also positive. Okay, so on the top here, this is gonna be your odd function. Okay, when you plug in negative theta, you're gonna get negative cosecant theta. So that's an odd function. And then these two cosine and the secant, that will be called even function. Example 1. If tangent theta equal to -5/3 and theta is in quadrant 2, find each function value. First, I want you guys find the secant. Okay, you should be able to draw the triangle in the quadrant 3 and figure out what is the hypotenuse. But here, I want you guys try to use the identity. So this one, I will using the tangent squared theta plus 1 equal to secant squared theta. You already know about the tangent theta equal to -5/3. So you could plug it in here. And then take square, that will be 25/9 plus 1. So you should get 34/9 equal to secant squared theta. And then we're gonna take the square root for both sides. And secant in quadrant 2 is also negative. So we do have secant theta equal to negative square root of 34/9. And then square root of 9, which is gonna be equal to 3. Okay, so secant theta equal to negative square root 34/3 here. Okay, B. Same question. We already know about the tangent and also we know about the secant from part A. Now we want to figure out what is the sine theta. Okay, so tangent theta equal to sine over cosine. We know about the tangent is going to be -5/3. Okay, but before that, we need to figure out what is the cosine. So first, I'm going to multiply by cosine for both sides. Okay, multiply by cosine theta here, multiply by cosine theta here. And cosine, that will be 1 over secant. And you already know what is a secant theta from part A, right? Tangent theta, that will be equal to -5/3. Okay, reciprocal for this guy, that will be 3 over square root of 34 times -5/3. Cancel out, negative, negative, you got positive. So you will have 5 over square root of 34. And then rationalize. We're gonna multiply square root of 34. So you should get this. Sine theta equal to 5 square root 34 over 34. Okay, C, cotangent negative theta. So cotangent negative theta, that will be reciprocal of tangent negative theta. And then we say tangent negative theta, that will be in quadrant 4, right? So tangent still negative. So that will be equal to 1 over negative tangent theta. And tangent theta, that is equal to -5/3. Simplify it, you're gonna get 3/5. Okay, caution, to avoid a common error when taking the square root, be sure to choose the sign based on the quadrant of theta and the function being evaluated. Okay, make sure when you take the square root, it's supposed to be plus minus, but you also consider like the quadrant of theta. Example 2, write cosine x in terms of tangent x. Okay, we could think about like the identity. We don't have the cosine here, but you know cosine x is equal to the reciprocal of secant. Okay, so we could flip it, take the reciprocal for both sides. And then 1 over secant, that will be cosine, right? And we want to find the cosine x, so we're going to take the square root for both sides. And then make sure you have the plus minus here. Okay, plus minus with the whole thing. And square root of 1, which is going to be equal to 1. And then we want to rationalize. So we're going to multiply square root of 1 plus tangent square x. And then this is going to be the final answer you're going to get. Okay, example 3. We're gonna write this guy in terms of sine theta and cosine theta, and then simplify the expression so that no quotients appear. Okay, we don't want to see any quotient here. So cotangent, that would be equal to cosine over sine. Cosecant, that would be equal to 1 over sine. Okay, now we do have the sine squared theta here. So on the top here, we're gonna multiply sine squared theta. And then on the bottom also multiply by sine squared theta. And we call this as gonna be the LCD, right? Now you're gonna distribute. Distribute the sine squared theta times 1. And these two you cancel out. On the bottom, do the same thing. You should get this guy. Okay, remember what is a sine squared theta plus cosine squared theta? That could be equal to 1, right? And then how about this one? What's a sine squared theta minus 1? That is equal to cosine squared theta, negative cosine squared theta. And then we don't want to see any quotient here. So 1 over cosine, that would be secant, negative secant squared theta. Okay, when working with trigonometric expressions and identities, be sure to write the argument of the function. For example, okay, don't write like this, sine squared plus cosine squared. You need the angle x or theta here. That's it.